Okay, maybe we should start.
Okay, sir.
Uh, I don't see any other. Let me share my screen. Uh, all right. So we'll start something of computational physics. So here, mostly learn about errors, approximation, numerical techniques for solving calculus problems. Okay. The screen is visible.
Yes, sir.
Yeah. Okay. Uh, have you got any study material on this paper?
Sir, the study material we have got, it has very less pages. Some links are given.
Yeah. So it is actually linked to a book. Uh, so I can also tell some this link to the same book in other format as well. Let me show it to you. Uh, let me come to my yeah. Might have got semester three computational physics, and then you may got numerical methods. Okay, just try to open it. Just let me see what happened. Yeah, this is what you are getting, right?
Yes, sir.
Yeah. So here actually, if you can see on page number 4, yeah, so, yeah, page number 4, huh? Page number 4, there is this link, this one, uh, which gives rise to this kind of numerical methods with application, numerical methods with application. This part is there, so that you can play around. All right, and then each like measuring error, source of error, binary representation numbers, floating point representation, propagation of errors, Taylor series revisited. All these things you will have some PDF doc format. So there you can download the PDF and read it. Okay, you get my point?
Yes, sir.
Yeah. So mostly, as I said, errors, approximations, differentiation, integration, and solving differential equations and simultaneous linear equations, interpolation, yeah, and regression analysis. That is what you will mostly be optimization, of course. That is what we will mostly be doing in this part of the course. It is very easy actually. The only thing is it's numerical technique instead of analytical. ଆମେ ଯୋଉଟା ପ୍ଲସ୍ ଟୁରେ ବା ପ୍ଲସ୍ ଥ୍ରୀରେ ଖାତା କଲମରେ କରୁଥିଲୁ ସେଗୁଡ଼ା ସବୁ କୁହାଯାଏ ଆନାଲିଟିକାଲ ଟେକ୍ନିକ୍ ମାନେ ଏକ୍ଜାକ୍ଟଲି ସଲ୍ଭ କରୁଥିଲୁ ଆଉ କିନ୍ତୁ there are equations ଯୋଉଥିରେ କି ଏକ୍ଜାକ୍ଟଲି ସଲ୍ଭ କରି ହବନି ତେଣୁ ସେଇ କେସରେ ଆମକୁ କଣ କରିବା ପାଇଁ ପଡ଼ିବ ଏଇ ପ୍ରକାର ମେଥଡର ସଲ୍ୟୁସନ ମାନେ ୟୁଜ କରିବା ପାଇଁ ପଡ଼ିବ ଓକେ so coming back to my notes so numerical methods are nothing but let me write it down so numerical methods uh, techniques to approximate mathematical processes. Okay. What kind of mathematical processes? This processes are nothing but mathematical processes such as integrals, integrals, differential equations, non-linear equations, etc. Okay. So for this purpose, we actually need approximation. So this is what I was telling that numerical methods are techniques to approximate, to approximate. So why approximations are needed? Why approximations? Why why approximations are required? Approximations are needed for number one. Uh, to solve, I mean, we cannot solve all problems analytically. We cannot solve all problems analytically. What kind of problems we cannot solve analytically, such as standard normal cumulative distribution, let's say, such as standard normal cumulative distribution. Okay. And what is that? Let's say phi of x is equal to 1 by 2 pi root of the integration from minus infinity to x e to the power minus t square by 2 by t square by 2 into dt. So this is a typical normal distribution. If we have to evaluate, if we have to evaluate this integral, this cannot be solved very easily by analytical techniques or by using pen and paper and formula. So for that we need approximations. Okay. And what other case we need approximation? Hmm? If the analytical method is intractable, if the analytical such as solving set of thousand simultaneous equations, solving a set of 1,000 simultaneous linear equations with thousand uh, unknown variables, thousand unknown variables. For finding a force, finding the expression for the force acting in the body. Okay, so that means like to give an example, let's say a1x or a11x plus a12y plus a13z is equal to b1 a 21x plus a22y plus a23z is equal to b2 a31x plus a32y plus a33z is equal to b3. So this is like x, y, z, three unknowns, and the one, two, three equations. So three linear simultaneous equations. So this can be solved by using matrix inversion method. So if we have instead of three, so this is like three equations and three variables. So here can be solved can be solved by getting the inverse of a 3 by 3 matrix. Okay, but for thousand equations with thousand variables, but for thousand equations with thousand variables, we have to find the inverse of a thousand x thousand by thousand matrix. So for that we need numerical techniques. So for this we need numerical approximations. methods. Okay. So there are a few other cases for which we also need. Uh, for example, if we want to solve an algebraic or a transcendental equation, uh, for solving algebraic or transcendental equation, I'll tell you what is that transcendental equation. If I try to give an example, uh, let's say uh, m by m naught by m naught minus ft is equal to e to the power u plus gt divided by u0. Okay. Uh, this is basically the reducing mass equation for a rocket propulsion. This is reducing mass equation for a rocket propulsion. For rocket propulsion, we need to solve this equation uh, to get the value of t, and for this we need approximation. We need approximation. There was approximation method to. Uh, uh, Next is interpolation. 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 Just one second. Okay. Interpolation. Interpolation is like suppose uh, you are given with values like x and y, you know, so x1, y1, x2, y2, x3, y3, x4, y4, like that. If I give an example, if I try to give an example, let's say, uh, for example, let's say I have 0, 0, 1, 1, 2, 4, 3, 9, 5, 25, 6, 36. So what will happen for 4? Anybody tell me what will be the value, y value for 4?
16.
16, right? Yeah, it's 16. So how do you know it's 16?
By seeing the relationship,
Yeah, so what exactly you are tracking there for 0 for 0 for x0, y0, x1, y1, x2, y4. So it's like 2 into 2 or 2 square. 3, it is not 3 into 2, but rather it is 3 into 3. So 5 also it is not 5 into 2 or 5 into 3, it is 5 into 5. 6 also 6 into 6. So it has to be 4 into 4, 16. So if I have this up to this point, if I have the values, so I have x values running from 0, 1, 2 up to 6. But I also have 5, but I don't have 4. So in between, for in between point, I can find out if I know what is the equation that governs. So equation that governs the data points. Data points. Okay. So what I need to do is I need to find an equation y is equal to x square. So from this is what is satisfying up to this point. So if all these points are satisfied by this equation, then I thought, okay, to get this value, I'll just use y is equal to x square, isn't it? So this kind of, uh, if I try to write down, uh, finding a mathematical function satisfying all the paired data points and then use that mathematical function hmm, for predicting any intermediate value is called interpolation. Okay. So what exactly we are trying to find? We are trying to find a relation which is y is equal to. We are trying to find a relation which is y is equal to f of x. We are trying to find that kind of equation. That's all. Okay. So that is called interpolation. So for interpolation, we need uh, numerical techniques or approximation methods. Next one is for curve fitting. Uh, uh, curve fitting. Curve fitting. Curve fitting, I guess many of you might have done earlier also. Suppose, suppose I am given with, so when you do some kind of experiment, what you get data in the form of x and y, right? So you have some x1 value, for that you have y1. For x2, you have y2. For x3, you have y3, like this, right? If I try to give an example, let us say we have a simple pendulum experiment. Simple pendulum experiment. Okay. So what is the time period? Time period is equal to 2 pi L by G root over, right? That is the time period of a simple pendulum. So if I square on both sides, it will be T square is equal to 4 pi square L by G, or G is equal to, oh, sorry, G is equal to 4 pi square L by T square. Okay. To find the value of to find the value of acceleration due to just a second,
ভাত খেতে
some
হলো।
small issue. Just 1 second. To find the value of acceleration due to gravity, uh, this is the relation g is equal to 4 pi square. Four pi square L upon T square. Okay. So if we try to use that, then uh, uh, what we need to do, we have for different length, for different, I don't know, my pen is somehow L upon T square, or L upon T actually, not T square, but L upon T, we get L and then we get. So for different lengths, let's say for 10 centimeter, 20 centimeter, 30 centimeter, 40 centimeter and all, we get the time period like 20 seconds, 30 seconds, or like that only, so on and so forth. So if we try to find out what is t square, we can just square it and get the value. Okay. And then what we have to do, we have to find out the slope. We have to find out the slope of this L upon T square. So what we have to do, we have to plot a curve. So here we have L and here we have T square. So from that, it will be a straight line. And from that, we have to find out the slope. Okay. And from that slope, actually, we can get the value of L upon T square, which will give the exact value of G. It will give us the value of G. Okay. All right. I think I will take a 5 minutes break and then I will continue. Okay.
Okay, sir.
ପତିତ ପାବନ ସାର୍ କାଲି ଯୋଉ ଆମର ଅପଟିକ୍ସ କ୍ଲାସରେ ମ୍ୟାମ୍ କେମିତି ସଫ୍ଟ କପି ମ୍ୟାଟେରିଆଲ ଦେବେ କିଛି କହିଲେ କି?
Ma'am, she has given her mail ID. I will send one message. She will give. If she will give, I will give in the group.
Can I get the email ID? I was not present yesterday class. Excuse me, sir. Can I get the email ID of ma'am? Thank you, sir.
So, sir, good evening. Hello. Sir, class कौन हला? हबो ना नाई?
କ୍ଲାସ ଚାଲିଛି ସାର୍ 5 ମିନିଟ ବ୍ରେକ୍ ନେଇଛନ୍ତି ତ ଏବେ ଜଏନ୍ କରିବେ।
Oh, ठीक ठीक।
Okay. Let me share the screen. Yeah. So other than uh, curve fitting, we also have numerical differentiation and integration. So for that also we need uh, these techniques, matrices and linear equations. Um, Linear equations, ordinary and partial differential equations. Okay. And there are also something called integral equations. Okay. Integral. So for these all these purposes, which cannot be solved analytically, we need to know some approximate methods uh, to solve this kind of questions. So approximation leads to something called error. Approximation. Approximation. So what leads to errors. So this is not exact, you know. This is not exact. So since mm, this is not exact, so this will lead to some kind of errors. So error means what? The exact value minus the observed value, right? Exact value minus the observed value, isn't it? That's kind of your error. Now, most of the time, how we represent is if we have a quantity x, mm, or a x required value, I would say, required value, is equal to x observed plus or minus some delta x. So delta x is the error. Delta x is the error. I'll give a very crude example. I'll give a very crude example. Let us say I have to measure the length of my pant. Let's say I have my pant. Okay, I have my pant. I want to measure its length. Okay, so how exactly I will measure the length of my pant? Maybe a scale. Sorry, scale or a meter tape. Meter tape, right? That's what you use the tailor, right? Meter tape. So what is the minimum length that can you measure using a scale?
1 millimeter.
Minimum length using a scale. Yeah, that's 1 millimeter, right? Or 10 to the power minus 3 meter. So if I got something like, let's say, 1.2 meter, if I try to express it in centimeter, it would be 120 centimeter, right? Millimeter, 1200 millimeter, right? Or if I try to write this in terms of meter, it will be 1.200, right? So why I am writing this? So when I say 1.2 meter, you hardly care about what is beyond 2. When I write 120, you hardly care what if there is a decimal point 1 or point 2 like that. When I said 1200 millimeter, these zeros are important. Isn't it? It's not 1250, it is 1200, right? So if I want to write the length of my pen, length of pen is equal to 1.2005 meter. Can I write this much using a scale? The question is, let us say I am writing that the length of my pen is 1.2005 meter. Can I measure this quantity using a meter scale?
No, no, sir.
No. I can measure only up to
Two, three places.
200,
Uh,
right? 3 places. This 5 is, even if I am writing after 0, I am writing 5, assuming that it is more correct, right? We know, all of us know, as many numbers after decimal gives more correct answer, isn't it? But here, this 5 cannot be measured. If I'm by some calculation or something, I'm writing this 5. This 5 is basically creating error. This 5 is creating error. So, error and uncertainty. There is a word called uncertainty. Uncertainty. What is it? Uncertainty is something like uh, unknown portion. Unknown portion. Okay. So, in case of a meter scale, in case of a meter scale, the uncertainty is of the order of 1 millimeter. So anything less than 1 millimeter, anything less than 1 millimeter is uncertain using a meter scale. Okay. So the error, even if I measure very accurately, the error in length measurement using a meter scale is equal to 0. Sorry, is equal to 1 millimeter. Okay. Or if I write it in meter, it will be 0.001 meter. So any length I'm expressing, this much will be the uncertainty, or this much will be the error. So I cannot accurately say, suppose I am writing my length is 1.20 2, 5, but this 5, I don't know, it could be 5, it could be 5, 6 also. Because if I have this kind of gravings in my meter scale, and somehow if it matches with this one or matches with this one, but if it is in between, but if it is in between, then this last digit is not accurate. So that gives rise to the concept of significant figures. That gives rise to the concept of significant figures. Okay. So that way we introduce some kind of errors. Okay. Uh, since the material is on the website, I think I cannot annotate that material is in my tab. So I will switch over to my laptop. So I'll possibly log out and log in again. So bear with me. Okay. ମୁଁ log out ହେଇକି ପୁଣି ଆଉ ଥରେ log in ହଉଛି ମାନେ to show the material from the web because I cannot annotate using my tab.
Okay, okay, sir.
So is my voice audible?
Yes, sir.
Yeah, there are some problem earlier. So, all right. So, coming to your material, let me share my screen. My screen is visible to you now, right?
Yes, sir.
Yeah. So this is the site website uh, where you can I can give it to you as well. Let me maybe write in the chat maybe that you can check afterwards. The book is available there. Numerical methods with application by cow. Okay, and there is another book actually by this you can easily get in local bookstore. In Introductory Methods of Numerical Analysis by S.S. Sastry. By S.S. Sastry. Okay, that you can get in one of the local bookstore. So errors in calculation basically that we are discussing, and let me come to the specific part. There are few theorems I would believe that would be very useful for you to remember. One such theorem is basically your Taylor series expansion. Taylor series expansion. Okay. So this part would be important. Just a second. So that we are discussing as yeah, this one over here. So this part would be quite important. Okay. So Taylor series function এটা সমস্ত পড়িছো Taylor series
Yes sir,
expansion
mathematical
ହେରିକା?
physics ରେ ଟିକେ ପଢିଛୁ।
Yeah, mathematical physics ରେ ମୁଁ କହିଲି ଜଷ୍ଟ ଫର୍ମୁଲାଟା ପ୍ରାୟ ସମସ୍ତଙ୍କର ମନେ ଥିବ, ମୁଁ ଖାଲି କହିଦଉଛି f of x can be expanded. So if this is my f of x can be expanded around x equal to a, around x equal to a. Huh? Uh, and how exactly we write f of x is equal to f of a plus x minus a into f prime a. F prime a is what? Df by dx evaluated at a. Df by dx evaluated at a. Next term would be x minus a square by factorial to f double prime a. F double prime a means it's a double derivative d square f by dx square evaluated at x equal to a. And then it will continue until what? X minus a to the power n minus 1 divided by n minus 1 factorial f n minus 1a. F n minus 1a means it is derivative with respect to derivative of f with respect to x. So n minus 1th order derivative evaluated at a. Okay, and the last term, this last term over here, huh? So that is basically called here. This last term over here is called the remainder term, and the remainder term can be written as like this: x minus a to the power n by n factorial f n xi. Instead of x, we are writing f n xi, where xi is basically this letter is called xi, and this is in between a and x. This is in between a and x. Okay, and Maclaurin series. The next one is Maclaurin series. So Maclaurin series is same as Taylor series. Only thing is here for Taylor series x around a, here x around 0. Instead of, so x minus a equal to 0, so that will be instead of x minus a, it will be x minus 0, which is x, and x minus a square or x minus 0 square, that will be x square by factorial 2, and x to the power n by factorial n. So it will continue like that. Okay. So why exactly this Taylor series and Maclaurin series are important? Now, a function f of x can be approximated. This is like an infinite sum, right? So if I take up to, let's say, 100 terms, if I take up to 100 terms, still it is not equal. It is nearly equal. Okay. So on the left hand side, it is a complete function. On the right hand side, it is the approximation. It is the approximation. So most of the time we use this Taylor series or Maclaurin series expansion to approximate the value of a particular given function. You are getting it? If you have function of two variables, so this is how the function for a function of two variables, the Taylor series expansion looks like. Okay. ସମସ୍ତେ ପ୍ଲସ୍ ଟୁ ବହିର ଯୋଉ ଫାଷ୍ଟ ୟୁନିଟ୍ସ ଆଣ୍ଡ ଡାଇମେନସନ୍ ସେଇଟା
Yes sir.
ପଢିପାରିବ ଟିକେ? Yeah, because that is very much important in understanding errors. I'm not, there is no point in repeating those techniques or those things. So it is already given like what is standard error, what is relative error, what is percentage error. All these things are kind of repetition, so there is no point. So I will move over to something called uh, numerical techniques solving transcendental equation by bisection method. By bisection method. Okay. Bisection method रे केमिति हमें गोटे linear equation को transcendental equation को solve करू सेटा हमें टिके बुझ. Okay.
लाइन ଅଛି ଯେ
So bisection method. So if we are given with the equation y is equal to f of x, and we want to solve for x, let us take a very simple example. Let's say we are given ax plus b, ax plus b equal to 0. This implies
ଏଇଟାକେ ଦେଖବ
ax is equal to minus b. This implies x is equal to minus b by solve, right? If I am given with, let's say, so let's say we are given with ax square plus bx plus c equal to 0. So how do you solve it? This implies x is equal to minus b plus or minus b square minus 4ac root over by 2a, right? This is what the formula you have used, isn't it? Now, if you are given with the equation ax square plus, sorry, uh, ax cube plus bx square plus cx plus d equal to 0. How will you solve it? I'll give a, this is general equation. I'll give a normal equation, let's say 2x cube 2x cube plus 3x square plus 4x, let's say, right? Minus 9 is equal to 0. So what will be the value of x? Can anybody tell me what will be the value of x for this equation?
So 1.
Yeah, that is a quick
Yes,
guess,
sir.
right? It is just by trial and error. So let us try one more, and then we'll move over to the difficulty what exactly we are seeing. Suppose I am given with uh, 4x cube uh, minus 20x, 4x cube minus 20x, hmm, plus 8 equal to 0. Okay. So what will be the value of x? What will be the value of x?
ବିଶ୍ୱାମିତ୍ର ସାର୍ ଆପଣ ମ୍ୟୁଟ କରିଦିଅନ୍ତୁ।
4x cube minus 20x plus 8 equal to 0. What will be the value of x? Any answer? Anybody working on it? Yes? Anyone? My voice is audible, right?
Yes, sir.
Yes, sir, it's audible.
Yeah, yeah. So are you able to guess it? It's a very simple equation. Okay, take 5 minutes, and then we will discuss something how to get this solution in a systematic way rather than just quick guess. Okay, you try for 5 minutes. If you can try your luck and to get the answer. It's a very small equation. Imagine if we have like x to the power 10, x to the power 9, x to the power 8, x to the power 7, like that only. It will be very difficult to guess. But this can be guessed, of course.
So this is also one, sir.
No, one it is not one. One will one work? 4 plus 4 into 1 cube
No, no, no,
is
sir.
4.
No, sir.
2 will work, right? 4 into 2 cube minus 20 into 2 plus 8. How much is 4 into 8, right? Minus 20 into 2 plus 8. So that is 32 minus 40 plus 8 is equal to 0, right? Isn't it?
Yes, sir.
So the answer is x is equal to 2, isn't it? That's one solution. But this is not a very scientific way to find the answer because quick guess, smart guess, these are like very uncertain words. There is something called method of bisection. Right? There is something called method of bisection. So what do we do? If you have a function f of x equal to 0, then you take 2 points, x is equal to a and x is equal to b, x equal to a and x equal to b, such that hmm, such that f of a is greater than 0 and f of b is less than 0. ତେଣୁ ଦିଟା a ଆଉ b ଦିଟା ପଏଣ୍ଟ ନବ ଯେମିତି କି f of a ଟା greater than 0 होतबो f of b ଟା less than 0 होतबो or vice versa or vice versa vice versa माने f of a ଟା less than 0 होतबो f of b ଟା greater than 0 होतबो आको ଆଉ ଗୋଟେ ଭାଷାରେ ମଧ୍ୟ ଲେଖା ଯାଏ ଆଉ ଗୋଟେ ତରିକାରେ କଣ ନା f of a into f of b should be less than 0 ମାନେ ଗୋଟେ ପଜିଟିଭ ଗୋଟେ ନେଗେଟିଭ ହେଲେ ସେଟାକୁ ମଲ୍ଟିପ୍ଲାଇ କଲେ ନେଗେଟିଭ ହବ। ତାହେଲେ ଯଦି ଏଇଭଳିଆ ସିଚୁଏସନ ହେଲା ତାମାନେ କଣ ହବ ଯଦି ମୁଁ ଗ୍ରାଫିକାଲି ରିପ୍ରେଜେଣ୍ଟ କରିବି ଏମିତିଆ ଏଇଟା y axis ଆଉ ଏଇଟା x axis ହେଲା ତାହେଲେ ଏଇଟା y ଟା ନେଗେଟିଭ ହବ x ଟା ଏପଟେ ନେଗେଟିଭ ଫଙ୍କସନ ଟା ଯଦି ପ୍ଲଟ କରାଯାଏ ସେଇଟା ଏଇଭଳିଆ ଗୋଟେ ଫଙ୍କସନ ଟା ଦେଇଥିବ y is equal to f of x ଆଉ ଏଇ ପର୍ଟିକୁଲାର ପଏଣ୍ଟ ରେ f of x is equal to 0 ହେଲା ମୁଁ ଯଦି ଗୋଟେ ପଏଣ୍ଟ ଏଇଠି ନେଇଛି a ଆଉ ଗୋଟେ ପଏଣ୍ଟ ଏଠି ନେଇଛି ଓକେ b ତାହେଲେ f of a ଟା greater than 0 ଆଉ ଏଠି f of b ଟା less than 0 ଯଦି ଏଇଭଳିଆ ସିଚୁଏସନ ହବ ତାହେଲେ ମୁଁ ଆଉ ଗୋଟେ ନୂଆ ପଏଣ୍ଟ ବାହାର କରିବି x1 which will be equal to a plus b by 2 ମାନେ a ଆଉ b ର ମଝି ପଏଣ୍ଟ a ଆଉ b ର ମଝି ପଏଣ୍ଟ let's say ଏଇଟା ହଉଛି a ଆଉ b ର ମଝି ପଏଣ୍ଟ x1 ଦେଇ f of x1 ବାହାର କରିବି I'll find out f of x1 and check এটা greater than 0 না less than 0 যদি f of x1 greater than 0 f of x1 greater than 0 ତା ମାନେ x1 ଟା এই সাইড কো ଅଛି যদি f of x1 less than 0 ତା ମାନେ x1 ଟା এই সাইড কো ଅଛି রাইট সাইড তাহলে ଆମ এই পার্টিকুলার কেস রে f of x1 is less than 0 because it is here. Now b টা যেহেতু এটা a টা f of a পজিটিভ f of b নেগেটিভ f of x1 নেগেটিভ now replace b by x1 ତା ମାନେ କଣ ହେଇଯିବ b ଜାଗାରେ x1 লিখিବି so now x2 will be equal to a plus x1 by 2 ମାନେ a ଆଉ x1 ର ମଝି ପଏଣ୍ଟ ଟା ବାହାର କରିବି ଏଇଠି ବାହାରିବ ଚେକ୍ କଲି ସେଇଟା ତାଠୁ 0 ଟୁ ଅଧିକା ତେଣୁ এটা ଯଦି 0 ଟୁ ଅଧିକା ହେଲା a ଟା ବି 0 ରୁ ଅଧିକା ତାହେଲେ a ଟାକୁ ନେଗ୍ଲେକ୍ଟ କରିକି ବର୍ତ୍ତମାନ ଏଇଟା ଏଇ ପଏଣ୍ଟ ଆଉ ଏଇ ପଏଣ୍ଟ ର ମଝି ପଏଣ୍ଟ ବାହାର ଏମିତିଆ ହେଇକା ଲାଷ୍ଟ କୁ କଣ ହବ ଗୋଟେ ପଏଣ୍ଟ ରେ ସେଟା କନଭର୍ଜ କରିଯିବ x equal to 0 ଆମେ ଯୋଉ एग्जांपल ଟା ନେଇଥିଲେ ସେଇଟା ଟିକେ ଚେକ୍ କରିବା कौन सेटा 4x cube minus 20x 4x cube minus 20x plus 8 equal to 0 let a is equal to uh, let a is equal to 1 1 the whole solution a equal to 1 1 नेले कौन होगा एटा मोर होची f of x टा so my f of x equal to 4 x cube minus 20x plus 8 then f of 1 is equal to 4 minus 20 plus 8 So that is equal to -8 less than 0. Okay. Maugute point notes let b is equal to 3. मैं arbitrary जेकोसी number नहीं करे 10 भी नहीं करे जितने अलग number नहीं भी number of iterations by number of steps body जीवा. For simplicity I took let me take it not 3 but let me take it 4. Then we will understand what exactly is happening. Okay. Let us take it 4. So my F4 which will be equal to 4 into 4 cube minus 20 into 4 plus 8. So this is 4 into how much? 4 cube 64 minus 80 plus 8. So which is equal to 64 into 4 256 minus 80 plus 8. So how much it is? Let's calculate using the calculator. 256 minus 80 plus 8. That's equal to 184. That's equal to 184. Now this is greater than 0. So that means f of a is less than 0 and f of b is greater than 0. I got my condition. So next my x1 will be equal to a plus b by 2. So which is equal to how much? My a was how much? 1. A was 1, b was 4. 1 plus 4 by 2 which is equal to how much? 5 by 2. So that is 2.5, right? So what is f of x1? Next I will find out what is f of x1. F of x1 is what? 4 into 2.5 cube minus 20 into 2.5 plus 8. Okay. Let me use my calculator to calculate. So 2.5 this is 62.5 minus 50 plus 8. So that is equal to 20.5. So this is greater than 0. This is greater than 0. Okay. If I have to see if b was greater than 0 and f of x1 is greater than 0. So now replace b with x1. So that will be replace b with x1. So my next x2 would be equal to a plus x1 by 2. A was 1 plus 2.5 by 2. So that is equal to how much? 3.5 by 2. So that is 1.7. 1.7. Now again you have to find out what is f of x2. That you can do, and you will keep on doing this until you get f of x is equal to 0. You keep on doing this until f of x is equal to 0. And see how I started with a and b, my guess, and then I am finding out the midpoint. I am bisecting. I am bisecting a and b. A plus b by 2, that means I am bisecting a and b to get the midpoint. Okay. And then using that midpoint, I'm checking what is the value of of x, and then again from x1 I'm getting x2, from x2 I'll get x3, from x3 I'll get x4. I'll keep on doing this until f of x is equal to 0, and that will give me the value of x. Now this looks very complicated when we ourselves are calculating, but computer is something which is meant for calculation, right? So if we can use the computer to solve this, it will be much easier. So that's why computational physics. Okay. So this is what is called bisection method. I will not go much further today. Next class, we'll be discussing something called Newton-Raphson method. How exactly we solve equations using Newton-Raphson. Okay. I would suggest all of you today to go through the site I gave you. You use that site to read. You just click and then it will open. You can read it. The error part, and then of course any +2 level book where units and dimension, the first chapter which is taught in +2, units and dimension. So read that chapter if you have available books, or you can go to NCRT website and you can find it. That is also available there. Okay. If you have any question, you can ask me.
Sir, the site means the site that is given in the material of IGNOU. That one.
No, no.
Okay.
I actually shared one site with you in my last message. I mean, when I was on my computer, I shared one link. Did you follow that? No, maybe I can just wait for a second. I may, I don't know if it will work. Just 1 second. Maybe I will copy it and give it to you. Just copy it. Just 1 second. Yeah, just check whether you are able to check the message part. Huh? Check the message in this Google Meet. Are you able to see the link? समझते लिंक टा पाइलो ना?
Yes, sir. Yes, sir.
So once you click, the whole book will come actually in chapter wise. Okay. So read the first chapter on errors. Read the first chapter on errors, and then we'll discuss few more techniques tomorrow. Okay. And also try to read a bit of units and dimensions chapter from +2. If you have any doubt there, you can discuss. But that is very basic that you have already read. That's why I'm asking to revisit that. Not something new. Okay. Any more questions? Okay. If no more question, I will possibly stop it here. We'll meet tomorrow at 6 and discuss more about few more numerical techniques. Okay.
Thank you, sir. Good night, sir.
Thank you, sir.